Hi, y'all. We're excited to have you here and welcome you to Flatiron School's Intro to Cybersecurity, the Power of Linux. My name's Corey Mickelson, and I am the Marketing Events Coordinator here at Flatiron School. A big part of my job is hosting free introductory workshops like this one right here, as well as tech talks where we cover hot topics in the tech industry. A quick reminder, we're going to be using the chat function as our main source of communication. So make sure to set that little blue button from panelist and host to everyone so we can all chat together. And that way everybody can see your questions as well if it's something that somebody else has. Without further ado, I'd like to introduce our host for the evening, Adam Colvin. He's one of our lead software or cybersecurity instructors. Take it away, Adam.
Absolutely. So thank you all for joining us tonight. Let me just get my slides up here. Oh, and we're going to say, oh, sorry, 1 second. Just getting everything lined up properly. Perfect. All right, you'd think after many or multiple years of working with meeting controls, I'd have it down quicker than that, but here we go. So today we're going to be doing the intro to cybersecurity and the power of Linux. The intended audience for this is anybody who's interested in learning a little bit about Linux at a good introductory level. So a little bit about me. My name is Adam. I'm a cohort lead instructor here with Flatiron Schools. I actually attended the SecureSet program, which is a subset of Flatiron now. At the time, it was not a part of Flatiron, but attended SecureSet schools and pivoted from the retail environment over into cybersecurity. First job after getting out of SecureSet was doing some work with cybersecurity. What was it? Risk analysis or risk assessment, cybersecurity risk assessments with a company up in Denver. After that, I transitioned into a managed services provider where I was responsible for watching servers for Ping identity products, which is single sign-on and other related workflows. From there, came back to Flatiron to teach as an instructor, and so far it's been a ton of fun. All right, so tonight we're going to be talking about a couple different things. First and foremost, we're going to be doing a brief history of Linux, and by brief, I mean a very brief history. We're going to do a little bit of review of what open source is and how, the pros and cons and everything that goes into open source. We're going to do a quick look at some Linux security. We're also going to look at some common uses for Linux, and then I'm going to do a brief Linux demo, just bring a couple of virtual machines and demonstrate a few workflows inside of Linux. All right, so first, our very, very brief history. I'm probably going to be missing all of the main points or some of the more nuanced aspects of the history of Linux and Unix. This is just supposed to be a very, very quick, like, hey, just so you know, this is where this came from. So again, very complicated history. With this, kind of the granddaddy of most operating systems today is Unix. It was developed starting in 1969 by Bell Labs, and it is to some degree still around today in the form of BSD, which stands for Berkeley Software Distribution. BSD Unix was originally just pure Unix, but was developed to be more Unix-like, which means it's still very, very heavily influenced by Unix, but is not technically purely Unix. BSD Unix itself is no longer maintained, but there are still versions being maintained, such as OpenBSD and FreeBSD. It's also extremely mature because it has been developed for over 50 years. And as a result, it is a very solid foundation to base different operating systems off of. The next one we want to look at here is the GNU Linux or GNU Linux. Linux itself was developed by Linus Torvalds back in 1994. He released kernel version 1.0. The LI in Linux refers to Linus's first name. GNU is actually an acronym, stands for GNU is not Unix, which of course is recursive because then new is back in the name again. So new is not Unix, and which is new is not Unix inside of that. Kind of fun and clever. There's a few of those inside of the open source community. It was originally developed by the Free Software Foundation and started out as utilities for the OS. Later on, GNU and Linux combined to create the complete system. It's officially called GNU Linux, but quite often people will just shorten it to simply Linux. With this, we also have two other major operating systems that people are probably familiar with. Windows, obviously, is actually based on DOS, or was originally, I should say, based on DOS, which stood for Disk Operating System. It was later based on Windows NT, never really Unix-based or never Unix-based, but I'm sure it pulled a lot of inspiration from Unix, should we say. Mac OS originally wanted to be Linux-based, and I believe they tried to pull Linus into their operation. Linus said no, so they went and decided to base their operating system off of BSD. Because both BSD and Linux are both Unix-like or Unix-based distributions, you'll actually find a lot of similarity in the file structure and how Mac covers and utilizes files. There's a lot of crossover with how Linux does their operating system. So Mac OS was originally released in 1984. And like I say, it's more closely related to BSD than it is to Linux, but they are very similar in many ways. All right, open source review. So first and foremost, looks like my words got a little overrun here. First and foremost, what is open source? So in short, open source software is any software or code that is freely available and public on the internet for anybody to go and look at. It also allows for folks to potentially contribute to that, or at least do code review. One very popular public software repository is GitHub. There are other options available if a more custom or private solution is needed. And again, comes down to, do you want a private software repository that only you have access to, or do you want something that's public out there for people to see? Public repositories are available for everyone to view, like I mentioned, and depending on the permissions set up on that repository, it's possible that anybody could potentially contribute to that. So if that means that you're reading the code and you find something that you don't like, or a bug, or just otherwise you want to be able to improve or help with that code, you may be able to directly submit a pull request. So go in and download that code, make your modification, and then submit it back to the code authors and see if they'll do a code review and merge it into the actual application itself. Or, if it's a little bit more locked down, there may only be select people who are permitted to actually do the coding, but you could still submit, a bug report and say, hey, I think this needs to be improved, or this doesn't look right. And that way you can help contribute to that code to make sure that the software is as good as it possibly can be. The nice thing with repositories is it does have versioning history. So if, for example, you wanted to run a test against a very specific version of the code, you should have that code history available to you. So you could go back to a specific snapshot in a specific moment in time and actually run tests off of that. Or maybe you decide, hey, I like how this code was going up until this point. I'm now going to fork it and, do something different with it. And when we talk about Linux, we will see that there is a ton of forks. All right. All right. So like I mentioned before, Linux is built off of Unix. The source code for various Linux distributions is publicly available if you seek it out. And there are pretty much countless Linux versions available these days. Other popular projects that are also open source include, but are not limited to, things like the Signal Messenger app that everybody, or not necessarily everybody has on their phone, but many people have on their phone. That is open source. Log4j is also open source, and we're going to talk a little bit more about Log4j in a minute here. And then the Python coding language is also open source. So if you ever wondered how Python works, the source code is out there available for you to see. Actually, on this slide, I have a screenshot of the APT as an application inside of Debian and Debian-based distributions that is used, excuse me, for package management. And so this is just, the very top of this particular file, but this file goes on for a ways, and you can actually see what all code is built into this. All right, so there are many, 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 many Linux distributions. Let's just start with the picture I have here. So you'll see that I boxed in a small area in the top corner of this tall, skinny picture. That boxed in area is just the area that I have kind of highlighted here in the bigger photo. And you can see Debian is marked at the center here. And you'll recall a moment ago, we were looking at apt, and that was out of Debian specifically, but it's used in many, if not all of the Debian-based distros. This photo here does, as you can see, just a teeny, teeny, tiny portion of all of the potential Linux distributions that are out there. If you want to see the full size version of this picture, which I do recommend going and look at because it is very interesting, is go to the Wikipedia page, look up, I believe it's Linux distributions, and this photo in full res should be there. It was definitely far too big to include properly here. Excuse me. All right, so we're looking at the Debian branch here. However, there are a number of different branches available. You'll notice that I put Debian with Ubuntu right next to it. That's because Ubuntu is a Debian-based distribution. When we look at Debian, Debian has a philosophy of utilizing 100% free software. You can still install proprietary software or software that isn't 100% free if you should choose to do so, but by default, Debian sticks with free software when you do your first install. Debian is extremely stable in the realm of Linux distributions, and part of the reason for that is that it uses older, proven versions of packages. So it is definitely not cutting edge when it comes to the latest and greatest of features, but at the same time, it's very stable as a result. So it's an excellent distribution if you want to create a server, or if you want to, install something on a desktop, laptop that is just going to work almost all the time. Just know that if you're looking for cutting edge, Debian probably isn't for you. Ubuntu, again, mentioning it here. If you look at this picture, I wonder if I can bring my mouse up here. Are you able to see my mouse? Let me see here. Corey, I don't know if you're still listening here. Yes, okay, cool. So if you look at my mouse here, we have our Debian up here. If you look, and hopefully this shows up through the resolution, but there's another big branch here that seems to have a lot of forks off of it. And this is actually the Ubuntu branch. And I believe if we look at the big picture, this orange line coming down is the one that will eventually feed down into this. So Ubuntu is an extremely popular version of Linux. Here, okay, perfect. So Ubuntu is a fork of Debian, and it's also referred to as being a Debian-based distribution, as I've said a couple times, as a result of it being forked as such. It is an excellent choice for new users or people who are just getting into Linux. And the primary reason for this is because it has extensive documentation around it, and is actually, if you run into a problem, chances are somebody already has a forum post somewhere that has solved it or is actively being worked on for resolution. What's really nifty is that Ubuntu itself also has a ton of forks coming off of it. So a few notable ones, Linux Mint is one of them. Pop! OS is also becoming rather popular as of late because of its focus on compatibility with NVIDIA GPUs as well as gaming. So it's a very popular distribution as well. But Ubuntu is one of these forks.
Looks like we have some questions in the chat. So when you say they're running Ubuntu on an old laptop, what are the risks or advantages?
Absolutely. So Lubuntu is actually Ubuntu at its core. The main difference is that it's running a different DE, which is a desktop environment. We're actually going to be looking at the Lu in Lubuntu in a little bit here when we get to our demo towards the end. But basically, the Ubuntu itself has a number of different versions, such as Lubuntu. Ubuntu, of course, is the core. You have Xubuntu, I think it's pronounced, which starts with an X. There's Kubuntu, again, I think that's how it's pronounced, which uses the KDE desktop environment. So the advantage of Lubuntu is it's extremely lightweight. So it's very, very little memory footprint, very little, CPU and whatnot resources, depending on what you're doing with it. So it has a very, very small footprint. So it's really good for old laptops. Some of the disadvantages is it tends to not look as pretty. So if you like looking at, pretty rounded corners of Windows 10 or whatnot, like you're not going to necessarily get the rounded corners in Lubuntu. That being said, you can still install pretty much all the applications in Lubuntu that you could do in core Ubuntu. So
one more question. What would be the difference between Debian and, let's see, Trisquel, official distro from FSF?
I would have to look to Matt. Is that a Debian-based distribution, or where would that show up on the chain here? Or do you know where it would show up on the chain? Seems to be Debian based. Okay. So what that would mean is, again, depending on where it pops up on here, if it is truly Debian based or if it is Ubuntu based, which is also Debian based by its nature. The main difference is that it's very likely using most of the code from Debian. However, the developers who decided to build, again, I'm going to probably butcher the pronunciation of this, but Trisquel, they've probably said, and this is part of what's cool about open source and forking, is if they look at Debian and say, this is a good base, but it's missing these features that I want, they can go in, take the source code, and then add their own features on top of it to build their own distribution. So there's probably some extra features in there. I don't know the exact difference, but that would be the main items you're looking at. Has no secure, let's see here. I see. Okay. Yeah. Oh, I see. It's distro from new. Yeah. So likely the items that are used for secure boot are proprietary software, probably free to use, but not necessarily, or there's a fuzzy gray area where between truly free and then something that's free but has licensing requirements. Something like, man, it has just escaped my brain. The zip thing that nobody pays for. I'm sure you guys know what I'm talking about, but it has literally just fluttered off into the WinRAR. There it is. All right, I see it in the chat. So WinRAR, you can kind of technically sort of use it for free forever, sort of, but you're not supposed to because there's licensing requirements. So if you're a company that's using WinRAR and you're not paying for it, then that's not good. It's technically free to download and technically free to use, but at some point when you pass your trial, you need to pay for it. But they don't disable the application. So that's why I say there's kind of like a fuzzy gray area between what is free and what is truly free. So truly free software, you don't owe any money to anybody. There's no licensing in that regard. And so since they've removed the secure boot functions, there's probably something where it's free to use, sort of, but there might be licensing or, yeah. Thank you guys. Literally, I always make jokes about WinRAR and it just headed into the ether. All right, so back to Ubuntu, same thing. So the Ubuntu developers said Debian is an excellent base system, very stable, good to work with. We're going to go and we're going to build our own distribution. And then we have Ubuntu. The main difference between all those different flavors, Ubuntu, Kubuntu, Xubuntu, Lubuntu, is just a different desktop environment. There's also Ubuntu Mate, and I'm sure there's others. Um, so yeah, Ubuntu tends to be more user-friendly than Debian. So, typically you would say, hey, start with Ubuntu. When you get comfortable, then start messing around with Debian if you want to, kind of get into the weeds with it. All right, the next big one is Red Hat. And again, if we look at our big list here, Red Hat is this red line about 2/3 of the way down. So there's a lot of distributions that are based on Red Hat. The most notable ones for sure are going to be CentOS. You have Red Hat, which is the core, and then you have Fedora. CentOS recently changed its distribution or its update method, which I believe we'll talk about a little bit later. So if not, I'll talk about it during the demo, which actually spawned up a few more versions of Linux to be created because folks didn't like what they chose to do with CentOS. So what's cool with Red Hat is a powerful distribution targeted at enterprise customers. Think of it, this is probably a bad comparison, but Red Hat is kind of like the Windows of the Linux world in that it has a lot of extra security features that enterprise customers require, but it also has really good support. So with free software, if you're just downloading it for free, you might ask, well, how does the company make money to support it and keep updating it? We'll also talk about that here again in just a second when we talk about the pros and cons of open source. But in the case of Red Hat, part of their model is they offer subscriptions that gives access to their repositories, as which is where you get all your software from for Linux. And then also they offer support subscriptions. So if you're working in a Red Hat environment, something breaks, you can call Red Hat up and say, it's broken, how do I fix it? And they will certainly work with you to get that corrected. The Red Hat line uses an extra security layer called SE Linux, and we'll talk about that a little bit more later, but it's basically additional permissions put on the file system to make sure that things are interacted with in a very specific way. Red Hat is more commonly used in the US compared to the next distribution in our list, and Red Hat is owned by IBM. The next one is, let me think how to pronounce this. It's not SUSE. It's not SUSE. It is, I'm going to mispronounce it. I'm going to call it SUSE. That is wrong. The people at SUSE actually put out a music video. It's kind of funny. If you go look on YouTube, there's a whole YouTube video about how to pronounce it. And he goes through the whole song. And I watched that song a couple days ago and I have just forgotten again how to say it. SUSE? No, SUSE is wrong, I'm pretty sure. Or at least is not what they would prefer to be called. Susie is also not what they would prefer to be called.
Spell that in the chat for me.
Say again?
Will you spell that in the chat for me?
SUSE. So, but the people put out a video on YouTube, and it's funny because they do like a full, whatever. Sussy, no. Point being, though, apart from the naming convention or how you actually pronounce the name, I always say SUSE. I know that that's wrong, but it's another powerful distribution targeted at enterprise customers. It's a very similar model to RHEL, which is Red Hat Enterprise Linux, so RHEL. It also uses SE Linux, and it's more commonly used in Europe, and it's owned by EQT, which is an investment firm over there. So typically, if you're coming in from Europe or European countries, you'll be more common with SUSE. Oh, SUSE. Okay, cool. Oh, and she found the video. Awesome. Okay, so yeah, it's more commonly used in Europe, but very similar to Red Hat. So definitely unique distributions, but they will each have their use case. All right, the next one on the list is Arch. And there is a huge meme on the internet. If you guys are familiar, you already know what I'm going to say. If you don't know what I'm about to say, you're going to know it, and then you're going to hear this everywhere. But anybody who has ever installed Arch will always walk up and say, I use Arch, by the way, just so you know. And the reason they do that is that it is actually a lot harder to install Arch. It's not impossible, and actually using Arch's Wikipedia or Arch's wiki, it's actually relatively easy to do. You just have to be very good at following directions. But what this means is instead of having a graphical installer where you just like click buttons and say install English, install, mountain time, install this, install that, you actually have to go in and manually specify where you want to install things, how you want to format your hard drive. You have to go and do all this stuff by hand. The advantage to this is that you get to be very, very specific as to what you want on your computer compared to just taking the default and getting, all the stuff you want and then a bunch of stuff you may or may not want. SUSE. SUSE, there it is from the song. Perfect. All right. Now, Arch is unique in that or somewhat unique in that it is a rolling release distribution. What that means, as opposed to having major versions where you have a couple patches in there every now and then, this would be more similar to Debian, which Debian is currently on version 11. And I believe they release a new version every year or every other year. But they kind of, work on developing, they have their major version, and then they'll do minor patches, feature improvements, security improvements, things like that, but very minor stuff. And then after some period of time, they'll jump from 11 to 12, and it'll be big feature changes and big development differences. A rolling release distribution, you basically install it, and then you're always getting the latest and greatest, bleeding edge packages. It's getting installed right away. As soon as the thing is ready to go, you're downloading it, you're installing it, you've got the latest and greatest. That does have a trade-off in that the advantage of having something like Debian is you have, well proven, good packages, they're stable, they work. With Arch, it can be less stable. Folks who have installed Arch would argue that any system instability is the fault of the user, and that is definitely true to some degree. However, if you find something unstable, you should be able to roll back to the stable version or to the one that works. The advantage of it, Arch is bleeding edge, so you're going to get latest and greatest. For anybody who's following, the new Steam, the Steam Deck that's coming out is actually using an Arch-based distribution. So they've taken Arch, they've done some modifications to it, and that's what Steam is basing their Steam Deck's operating system off of. There's a distribution based on Arch called Manjaro, and that one is the one that I believe Steam has recommended people mess around with if they want to get a head start on that Steam OS. All right. Slackware, I don't have a ton of notes on this one, but Slackware is the oldest still maintained Linux distribution. On our big tree here, it's actually this blue circle at the top. So that's been around the longest. Debian was released shortly thereafter. Slackware is also kind of cool because it was the predecessor to, I'm going to double check, SUSE. It was the predecessor to SUSE, and then if SUSE eventually branched off and is no longer using Slackware as its base, it is its own thing now, but SUSE was originally based on Slackware. I do mention Android in here, and I put a sort of because Android does use a version of the Linux kernel, but pretty much everything else about it is completely unique to Android. So technically Android is Linux. So if you have an Android phone, you've been using Linux to some degree, but it's not a traditional Linux as one would think of these other distributions. These are just the ones I wanted to highlight because they're kind of the most popular, the most common, but again, I recommend looking at this picture because there are hundreds of different distributions that you could potentially mess around with. There are definitely also meme Linux distributions as well. So people who have just gone in and had a lot of fun creating it, but I would never use it for my daily driver, to be certain. All right. So again, we talked a lot about the different distributions. Now back to open source. So open source is a double-edged sword, to be certain. There are a lot of advantages. For one, anybody can see the code. What this means is if you're a software developer or if you're interested in code, you can go in and look, and if you find a problem, you can responsibly disclose that to the developers and say, hey, I found a problem. Let's fix it. Let's get this corrected. Let's, make this product better. By comparison, if you have proprietary locked down code, you are potentially looking at something like Microsoft. If there's a bug in Windows, nobody's going to know about it except for the excuse me, except for the Windows developers, until somebody finds a way to break it or exploit it. It makes it a lot harder to provide, potentially valuable feedback to Microsoft to say, hey, we noticed in the latest update, you added this little bit of code. And if improperly treated, this code is going to cause a lot of problems for your users. Now, that's not to say that Microsoft isn't constantly doing code review internally, but when you look at the size of the entire internet compared to the size of a couple hundred or a couple thousand Microsoft developers, there's a lot more eyes potentially see something that somebody doesn't see otherwise. An advantage is, like I just said, anyone can contribute. So if you find something, let the developers know, and potentially you're helping to improve this piece of software that is out there in the world that many people are using. I use the Signal app. I would hope if somebody found a vulnerability, they would tell the Signal developers right away so that I can keep my chats secure and safe. One other advantage of open source is it's free. So if you know how to compile code, you can go to GitHub, find some code, download it, compile it on your computer, and you have that application. Quite often, these open source folks will provide some kind of installer, so you don't have to go the route of compilation. But if for whatever reason you choose to not trust the installer provided by the software vendor, you can just go find the code itself and DIY and create that software after doing code review and looking at it and saying, okay, good, they didn't put any backdoors in there. With something like an operating system, that is many, many, many thousands of lines. So good luck. But you'll be certain you know every single thing that's in that operating system. Now, kind of in a cheeky way, I put for a disadvantage, also, everybody can see the code. So while we hope that everybody on the internet is altruistic and friendly and going to help everybody be better, there's also the people who are going to look at the code, find a bug in the code, and either keep it to themselves or sell it to somebody who has malicious intent. So this is always the argument from somebody like Microsoft or somebody like, or somebody who's running a closed source program. Hey, if everybody can see the code, then they can see what we're doing and they can steal it. So imagine if we had Windows and then we had a fake Windows right next to it that was all the exact same code, just slightly different, but you could get it for free because it's open source now. So they're trying to protect their IP and they see it as a potential security risk to let their code get out there. Again, because we're putting that code out there for free or available to the public, it can be very hard to monetize your code. So if you could download and install your own Windows without, or just compile your own Windows, there's no incentive for you to go to Best Buy or eBay or whatever and go buy yourself a code for Windows. But that being said, many open source projects will offer a support plan, which will allow them to help fund their day-to-day activities. So it's not as big a deal as it might seem on the surface. The other problem is contributions are voluntary. So depending on the nature of the open source project, updates and patches may only be delivered in the developer's spare time. If there's some application that somebody's just writing for fun on the side, but then it suddenly becomes super popular or super useful, and then there's a vulnerability found in that piece of software, that vulnerability may not be patched for a long time, depending on how much free time this person has. Imagine if you're pulling a 40-hour a week job or longer, you're working more, you may not have time to go back and work on your code every night. And again, if there's a problem identified, this is a fun side project for me. I'm not going to lose sleep over this. Let's see here. Yep. And depending on the size of the team, problems can creep into the code if you're not being careful about it. Now, I said I was going to talk about log4j. You probably heard in the news somewhat recently, if you've been keeping up with anything in the technology field, there was log4j had a huge security vulnerability. It was also referred to as log4shell. The, again, super oversimplified version of what happened is log4j is a logging application or a logging framework that is commonly used in Java applications. So what this means is if you build a Java application, you can go in and DIY and build your own logger and, get your log files out of your application by doing it yourself. Or there's this awesome open source project called Log4j that's already done all of this for you. So let's just grab that open source code, shove it into our project, and we have a fully featured logging capability just in our application. We don't have to waste time reinventing the wheel. Log4j is, again, maintained. Let's see. How long does it? All right, so the question is, how long does that have to be known for it to get trickled down to be a Minecraft exploit? So when we're talking about vulnerabilities and exploits, there's something called a 0 day. And basically what that means is it is a 0 day, meaning this is the day we found out about it. That being said, I believe the issue that was in Log4j was in there for years or was in there for a very long time. But because nobody had found it and nobody had figured out how to exploit it, it was sitting in the code for ever, but nobody was taking advantage of it. Nobody knew about it, so it was just sitting there. Once it was identified that it was extremely dangerous and extremely exploitable. So people moved very, very quickly to try and patch it. And the reason Minecraft was exploited is Minecraft is a Java application. There's two versions, there's Bedrock and there's Java. The Bedrock is, I believe, C or C++ based. It's something developed by Microsoft. The Java one is Java. And like I said, Log4j is very commonly used inside of Java applications for its logging. Yeah, people had to be exploiting it for years before. So it's entirely possible that the exploit in Log4j was being exploited in the wild before we knew about it. And that's the whole point of the 0 day is we didn't know about it until the day it was announced. So it's entirely possible that somebody was exploiting it, but we have no way of going back and confirming one way or another whether or not it was exploited. That being said, there are also things called indicators of compromise. So if we look at how something is exploited, those exploits tend to leave thumbprints behind. And if we find those thumbprints in our environment, we can say, Log4j was exploited in our space. But again, depending on how long you keep logs or how long you record certain aspects of your environment, those thumbprints might get erased very quickly. So yes, 0 day, that's another definition of that. Manufacturer has known about it for 0 days before it was exploited. And not even necessarily exploited. Manufacturer has known about it for 0 days, so we need to start patching it. We found out about it today. We're going to start working on fixing it today. Hopefully we come up with a solution very quickly. So 0 days are very, very valuable too in the wild. Like I said, when we're looking at code that's publicly available, if you're the malicious type who's looking at this code and you find a vulnerability and you take that and you go sell it to someone, you're basically selling a 0 day. You're not telling anybody about it, but you're selling what will become a 0 day someday. And somebody can be immediately exploiting that. But the 0 day is when we find out about it. When I say we as the cybersecurity community as a whole. All right. So again, Log4j, due to its ease of incorporation, why reinvent the wheel? It was thrown into a ton of projects, but because it was a very small development team, this bug worked its way in. They didn't have the time to do the code review, or just it missed code review. And now it's on tons of servers everywhere doing all sorts of potentially nasty things. So yes, so I've been talking about 0 days from a malicious standpoint. Mark also mentioned as a bug bounty, 0 days can also be lucrative money as well. So the black hat side of things, the evil side of hacking, if you will, or potentially evil depending on your viewpoint, is taking that vulnerability, that 0 day, and selling it to someone for illegal purposes. You can also go to the software vendor, and a lot of software vendors will have a bug bounty program. What that means is you get to go poke at their system. If you find a problem, you can go talk to their security team and say, hey, I found a problem. I'm responsibly disclosing this, meaning I'm disclosing it in a private, just me and you know it kind of way. And as a result, the company will say, excellent, that falls into our bug bounty program. That'll be 15 grand we'll give you, or 100 grand, or whatever. So, and yes, that is also very true, Matt. Bug bounties tend to pay way less because the bug bounties tend to pay less than the black market, because obviously those criminals really want whatever they can get because they think they can make more money with it. So again, black hat, white hat, gray hat, you have to decide what side you're on. Hopefully you guys choose to stay on the white hat and gray hat side. Keep our stuff safe. So, all right. The final disadvantage, which is kind of what I was alluding to with Log4j, is that support falls to the community. So if you have some small project like Log4j, you're reliant on a small subset of developers. If you have some community-based project, then you're relying on that community to come together and, make sure it's updated, make sure it's well documented. Documentation is one of the hardest things with open source software. There's some documentation that's really, really good. So as an example, the Arch Wiki, excellent resource, even for non-Arch distributions, because Linux is all very, very samey. There are some things in the Arch Wiki that will translate over to Ubuntu. Not everything, but there is a lot of crossover there. And then you have other things that are perhaps less well documented. Think about if there's some plugin that you downloaded off of the internet that maybe they haven't had the time to document it, or they don't have a full troubleshooting guide, and more than likely they definitely don't have a support phone number that you can call and be like, hey, my OBS studio is broken, like how do I fix it? Or if there is one for OBS, you're paying a lot of money for it. So all right. So sorry, I was reading a question from Matt again. So OpenSSL, he says, is done by a small team. I'm not actually sure how big the OpenSSL team is. I'd have to do some research on that one. But that being said, if it is a small team, he's asking why doesn't Microsoft or Google, some other big company, hire devs to go and contribute? And that is absolutely a thing that they probably do. If it's something that they have a vested interest in, they might divert some of their resources to go and look at it. I believe as a result of the log4j exploit, somebody was actually going to the US government and saying, hey, we need to fund these small program or these small things so that they can have the development tools that they need. One thing to keep in mind is that if you are talking about an open source program, those open source program engineers probably don't want Microsoft and Google and Amazon's, and they don't necessarily want all their fingers in there, because with that extra contribution, with that extra help, what is to say that the Microsoft devs aren't going to go in there and do some little manipulation to SSL that will still allow it to work with Macintosh, but will just make it less convenient to work with a Macintosh computer. But really convenient with Windows. And now suddenly this OpenSSL that's supposed to be available for everybody on the internet, or that is being utilized by everybody on the internet, now works slightly less good for their competitor. So it's something where having the resources of these big companies behind these open source projects would be extremely valuable and extremely useful. But you have to also balance and make sure that those big companies are not then turning it into a Microsoft product or turning it into a Amazon product. So it's kind of a balance there, like, get off my front yard. So, all right. We are going to keep pushing. Keep the questions coming. I'm loving them. All right. So Linux security. Oop. Providing financial support. Again, financial support is absolutely something that the big companies could do. Then you run into potential problems with, again, influence. So Microsoft may say, hey, here's $50,000 a year. Here's $100,000 a year for your project. We like what you're doing. Keep doing it. If At some point, OpenSSL or any open source project, whatever it may be, if OpenSSL chooses to diverge from what Microsoft thinks is good, then Microsoft can say, hey, stop that. We want you to go this direction, or else we take away our funding every year. And again, that is more potential influence that Microsoft or the other big companies could have on a small company, even if they're just donating money. So I believe that happens a lot with our education system. There's like certain things where I'm kind of talking out of my realm here, but I believe there's some things where the state government or the national government will provide some money and some extra cash so long as the state does X, Y, and Z. If the state stops doing X, Y, and Z, then that money just gets pulled right away. So again, there's lots of ways to potentially manipulate a project, and it's a delicate balance between, yes, we can use these resources, please give us money, and oh, we are now just basically a subsidiary of Microsoft, because if we stop doing Microsoft stuff, the money dries up and we're back to square one. So let's see. Sorry, reading the latest question. That's interesting. So they're asking for matching contributions. So more donations. And you can certainly donate. There's nothing wrong with donations. Just what I'm saying is that probably the reason why big companies may or may not contribute to something, or why a open source project may or may not accept money from a given company, could be related as we're talking here. I know that Microsoft has actually done a lot for the Linux community lately, either through direct contribution or otherwise. As an example, we'll talk about this when we get to the demo, but you can actually run Linux inside of Windows natively using their, and my brain just keeps, oh yeah, WSL, Windows Subsystem for Windows Linux Subsystem. My brain has just kept throwing stuff out all night long, stuff that I use all day, every day, and names just escape me. All right, so I'm going to push on here for a little bit and we'll get back to questions in just a little bit. So when we look at Linux security tools, there's a lot of stuff that they have going for them. Similar to other distribution, there are file system permissions. So again, you can look at a given file and say, this is readable, this is writable, this is executable, and then you can define who can do what with those settings. That way, if you want to, you can have a base user that doesn't necessarily have root access to the system, or which root is kind of like super mode, able to touch everything. You can have just limited, like, hey, you can just touch your user folder, you can open your Firefox, you can open your Steam, but you can't touch anything else in the system. One thing that Linux does that's really cool is they have something called the sudo function. So this is also present in Mac computers as well. If you've ever had to type a command that says sudo and then some command, what you're doing is sudo will allow you to temporarily become the root user. Again, root is kind of that God mode, access to everything, I can do what I want. Let's see here. Oh, just debate going on in chat. So sudo gives you temporary powers as the root user, and then as soon as you're done doing what you're doing, it de-escalates you back down to a lower level. The equivalent in Windows is to right-click and run as administrator. And again, administrator kind of has God mode permissions over Windows. It's a little bit, it's not quite as powerful as root, but it still has a lot of power over the system. The difference is you have to right click, run as administrator, and then as long as that window is open, that window is running as administrator. As soon as that window closes, you are now no longer administrator. You also get this a lot when you get the pop-up that says, hey, computer or programs trying to change settings on your PC. Do you want to allow it? And then you say yes or no. All right, so file system permissions is one of them, and then temporary root escalation. Another one is SE Linux. I mentioned that briefly. SE Linux stands for Security Enhanced Linux. These are most commonly found inside of SUSE as well as Red Hat. And I believe you can install it into other distributions, but it's not typically installed by default. It adds additional rules to files to only permit those files to be used or executed in specific ways. These rules are a lot more nuanced, and they add additional security instead of simply relying on having all files be read, write, or executable. And one example is if there are rules not explicitly in place allowing a computer or user to read from a plugged-in USB device, then nobody will be able to read from that USB device, including root. So root, who has master control over the entire system, if there's not an SE Linux profile in place, root will try and reach out to that USB drive and won't be allowed to touch it. This is actually really, really useful because if you have a malicious USB drive get plugged into your computer or get plugged into a server, you don't want that to automatically run. You don't want that code to be executable by anyone. If root were to reach in there and touch stuff, it could potentially install malicious software. Another one is containerization. This allows for multiple microservices and applications to be run inside of a single host while still being isolated from one another. Again, this is an oversimplification. It's kind of like a virtual machine without being a virtual machine. You're running these applications in your operating system. It's all using the same operating system. It's using, shared resources from this operating system, but it's not a full VM, which we'll talk about those a little bit later. So it's a way to run multiple services on a server, so you're sharing resources, but still providing some isolation between those services so they don't potentially impact one another. Host-based firewalls, pretty basic. It's just a firewall that's sitting on the host. So you can set up firewall rules that say accept connections from here, allow connections to there. But just like a normal firewall that you might find on the network, this one is just based on the host itself. Encryption. So Linux does support full disk encryption. You can also encrypt your swap file, and of course it does TLS and all that as well. So Linux works very well with encryption. A quick note on viruses and malware. Viruses and malware do exist for Linux machines. However, they are not nearly as common as viruses are for Windows. And then even for Mac, there are a handful of Mac viruses out there, but they're just not as common. This is more to do with the fact that the market penetration is kind of small. So, if you're going to target someone, do you want to target 95% of the computer users or even 75% of computer users? Or do you want to target 1% of computer users? If you have a specific target that uses Linux, you're going to write malicious code for Linux, and therefore it is a virus or it is malware for Linux. But in general, most malware is written for other devices. Another big area to watch for malware is something like Android. There have been in the past, and there will be in the future, malicious applications that get loaded into the App Store. And every now and then, Google will go in and actually pull applications off the App Store and go and uninstall it from your phone because it was malicious. Cell phones are an excellent vector for attacks because there are so many of them out there in the world. And on top of that, for anybody who has ever sideloaded an app, the reason you have to sideload it is because it's not on the App Store. But by enabling sideloading, you're basically allowing other things to potentially install themselves on your device. So it's an increase in risk, but depending on your use case, you may decide, I am willing to accept that risk to install that extra application. Now it's, more open and easier to work with, but if you download a bad APK file, you've just installed a malicious application that's doing who knows what on your device. All right. I see some chatter going on in the chat, so I will rely on somebody to condense that down for me a little bit later because I want to keep pushing. All right, common uses for Linux. I've already mentioned some of these, but most commonly web servers, file servers, authentication servers, media servers, game servers, and Linux, and I'll talk about Linux and Windows in a second. So web servers, any web page you go to, there's a very, very high chance that it's a Linux-based server. Windows does have a web server that it offers, but it's not nearly as commonly used. Again, file servers, this would be like if you had a NAS or something sitting on your network that you could go and log into, download a file from do some stuff with it, upload the file, and then somebody else in the office can come in, download the file. Again, these are file share servers. Authentication servers. So if you set up SSO, you're probably hosting that on a Linux server, unless you're doing something that is specific to Windows Active Directory and Active Directory services. So you can put all those SSO utilities on a Linux server. Media servers. People may be familiar with this. There's a media server called Plex. You can actually install Plex into a Linux server, put all of your movies on that server, and then basically make your own Netflix that you can go sit upstairs and watch your movies, and it all just sits on a computer somewhere. Netflix, I believe I looked, Netflix actually uses BSD. So that's the other half of the Unix fork there. But, BSD is very similar to Linux. Game servers. So you can create a Minecraft server, and with that Minecraft server, you can host your little Java application on there, and then your game client will reach in and tell everybody where everybody else is, what blocks have been destroyed, what blocks have been created and placed, and that's all probably running on a Linux server sitting in the background. Again, unless it's Microsoft, in which case, Halo probably runs on a Microsoft server. If I had a guess, I don't actually know, but ones that I do know have Linux compatibility: Minecraft, Ark, and Valheim, I know are all reasonably popular games at the time. They all have Linux clients. So you could, if you had a extra laptop sitting in your house, you could potentially install one of these game servers on there and then have a place to play privately with your friends. All right, when it comes down to Windows versus Linux, Windows can offer many, if not all of the services that Linux can, but it tends to be more of a walled garden. There's a lot higher licensing fee. Windows does require a bare minimum of 32 gigabytes of hard drive space. But if you do exactly 32 gigs, you don't have a lot of space for anything that isn't Windows. Linux servers can usually run without a GUI, which is the graphic interface, being able to click on things, which helps to save on resources. If you're not loading a GUI into memory, that's memory you can use for other things. Windows does have some GUI-free versions, so minimal versions, but the features on these GUI-free versions are relatively limited when talking compared to the full Windows server lineup. Linux also has free options. So if you're sitting here hosting a game server, do you want to pay multiple thousands of dollars a year to have a Windows server running your game? Or do you want to take the free one? Hey, let's take Debian, we'll put our game on here. Or do you want to take, Red Hat? You maybe pay a licensing fee, but trust me, Red Hat is a heck of a lot cheaper than a Windows server. Yeah. Now, all that being said, Windows does have extremely solid support, or at least more solid support than a lot of Linux distributions. So you have to decide what is important to you. All right. For the user endpoint, this is talking about laptops and whatnot. Linux tends to be really good for developers, really good for network engineers. It's getting better for video games. So Steam Deck is coming out. We'll see what that does. Every year, people are like, it's the year of gaming on Linux. It's the year of Linux. It's going to become mainstream. Hasn't happened yet. Probably won't happen this year, but you can always be helpful. Creators. So there's open source software programs such as Blender, which can let you do some 3D rendering and whatnot. There are open source versions of Photoshop. So that's also available. It may or may not run quite as smoothly as Photoshop does, but it's also free. So, take it. And then just general users. I have more than once had somebody come to me and say, hey, I need a laptop. And I'm like, cool, what's your budget? And they're like, $0. So I will go and find an old laptop laying around my house, install Linux on it, and say, here you go. These are mostly users who just use the web browser. So it's basically just a glorified way for them to get to the internet. But, they still want the full desktop experience. They want to be able to write Word documents or, be able to edit files and look at pictures on their laptop. So excellent way to revitalize old computers. Last but not least, we also have mobile phones. So obviously we talked about a little bit about Android. There's not a whole lot more to add to this because this is still a market that hasn't been fully tapped. Ubuntu does have a distribution called Ubuntu Touch. You could potentially install on your cell phone. It is a lot closer to a full Linux install than, say, Android is, but it still requires a lot of development for it to be, really useful in the day-to-day. All right, I'm going to pause briefly for questions as I get my demos set up. Do we have any questions that I missed while the chat was scrolling, Corey?
It looks like everybody's been answering questions. I've been answering everything in the Q&A that I could. So anything that I could Google and come up with. So if any of those answers seemed weird, that's because I was coming up with them, guys.
All righty. All right, I'm going to stick that aside for a moment. And I'm going to change my screen share here. All right, hopefully this doesn't crash my laptop. We'll find out. All right, can we see my screen? Oop, I don't have chat up anymore. Let me bring that up real quick.
I can see it. That looks a little bit small, but I can see your screen.
Okay. I mean, so long as you can see the window in here. So I'm going to be making things a little bigger as we go.
Okay.
All right, so I prepared 3 different virtual machines for us to work with here. So just real quick, what is a virtual machine? I said I would talk about that briefly. Basically, a virtual machine is a way to take an operating system and run it inside of your operating system. So there are a couple different options on how we can do this. One of them is the subsystem for Linux. And so if you install the subsystem for Linux, this is Bash, which is the shell application that Linux uses. And with this, I can run all the normal Linux commands and do Linux things right here in Windows. This is really nice because it's very lightweight and it's easy to quickly spin up. And here we go, I'm in Linux here. And I can also interact with my base operating or base file system. So if I wanted to look into my downloads, I could figure out where the path is on my system and get to my downloads or my documents or whatever. I actually use this a lot in tandem with VS Code, which I don't know what I was working on last. So let's get rid of that. Oh, that's funny. So I actually went in here and I did a little bit of HTML. I'm definitely not a web developer, but I did a little bit of HTML that we're actually going to see here in a little bit. So I could potentially take this code. HTML doesn't really run per se, but I could write a Python script and I could use that or run that against the subsystem here instead of having to spin up a whole VM just to get a little bit of a script running. For any of you who have or haven't seen this before, this is the Windows terminal application. You can get it on the Windows Store. It's super nice because you have PowerShell here, and then you can also do command prompt. And if you have any of the subsystems, you can have all of these just running in different tabs. So super, super useful if you do a lot of terminal stuff. All right, the very first one we're going to look at here is actually our Ubuntu desktop. So while this is spinning up, what we use at Flatiron is we use VirtualBox. It is a awesome application that is free and open source, made by Oracle. So you can actually download this yourself if you wanted to and start installing VMs. If you have Windows, you can also use Hyper-V, which is built into the operating system. And I believe for Mac, there's Parallels is what their virtualization software is called. That being said, VirtualBox runs on Windows, Mac, and Linux. So if you get familiar with it, you're good no matter what platform you end up on. All right, so this is Ubuntu login screen. I can type in my super duper secure 4-character password. That being said, this, while it's connected to the internet, none of you can find it. So, or I hope none of you can find it. We'll see. It's behind several NAT firewalls. So, and this is basically Ubuntu. I'm going to try and full screen it and see what happens here. Let's close that. Boom. All right, so this is what it would look like if you were just sitting in a Ubuntu desktop. From here, you can actually open up a terminal. And again, this is the same terminal we were just looking at, ping 8888. And there we go, pinging the internet. What's nice with Ubuntu is if we want to install a new application, let's see if I did. Nope, I didn't install Steam yet. So what I can do is I can actually open up my terminal. There's multiple ways to install software. This is one of them. So we can say sudo, we're going to give ourselves super user permissions. apt is that application we looked at with the source code for Debian. So we're sudo apt, and then we're going to say install. I believe it's just Steam. Type in my sudo password. It's going to say, hey, look, we got a whole bunch of libraries we're going to download. Do you want to download this? It's going to take half a gig of memory if we do this. I say yes, and now Steam is installing. Another one is many distributions will have these app stores, or basically it's a GUI for apt. It's another way for you to get in there and see exactly what software they have available. What's fun is that I believe they actually made the quote unquote app store in Linux before they did it in any sort of mobile OS. Now, because this is a VM, it's sharing resources off of my main computer. I have assigned it 2 GB of memory, and I've assigned it 2 cores off of my 4-core system. So this is going to run a little bit laggier and a little bit slower than if I had just installed Ubuntu straight onto my system. But it allows me to get in here and kind of experiment and work with it. What's also really nice, again, when I say experiment, I can get in here and I can break it if I want. I can, try downloading an application, and if it ends up being a bad app or something crazy goes on with it, I can just delete the VM and I don't even have to worry about it anymore. Something else I can do is do snapshots. So if I think I'm going to do something that's a little risky, I can take a snapshot before I do the risky thing. I can try the risky thing, and if it doesn't work, roll back to my snapshot, and it takes me 30 seconds to get a computer back to clean status. And, super easy. So here's VLC. So I finished installing Steam on the side. Let's say I want to download VLC. This is an open source video viewer. I can just click install, put in my password again. And I did not test this in advance, so it should work, but my demos always seem to fail at the last second. So hopefully this does its thing. It should be chugging in the background. It's probably doing a sudo apt install VLC in the background. And yeah, we'll let that chug for a minute. If I come back to here and I type Steam, we can see that Steam is now installed. And again, if I had my account details, I could sign in and download a game and get gaming if I wanted, but I'm not going to do that right now because we are running low on time. All right. So I'm going to put that back in a corner. I'm actually going to pause this. So I'm going to save the machine state. What that does is basically, it's like a save state if you've ever, played on one of them gray, emulators, but just takes a copy of the memory, saves it, and then if I want to, I can restart this virtual machine and I will be exactly right where I was when that machine went offline. The Ubuntu server, I'm going to do a quick example with this guy here. I'm just going to double check a setting while that one's booting up. Oop. Guess I shouldn't open that window before. Oh, I put it on yellow. Cool. So I'm actually also going to start up my Debian at the same time. All right, so I have a Ubuntu server that I'm starting. So this is almost identical to the Ubuntu desktop that we just looked at. The main difference is there is no GUI. So I can only interact with the system by typing commands into it. This is really nice because in this case, this is a web server. So this web server, or it's not a web server yet, we're going to make it a web server. Well, we will if it finishes loading its essential drivers. Worst case scenario, I'll just make Debian a web server because It's really easy to do. So here's my DE demo. So I talked about DEs a few times. This is desktop environment. When you install Debian, it actually has a bunch of DEs available by default. Usually distributions will kind of stick to one DE and optimize their environment for that. But Debian is kind of like, we want to work with everything. So these are all the different potential desktop environments we have. We have LXDE and LXQT. I don't remember which one is with Lubuntu. I think it was LXDE and they're moving to LXQT. We'll take a quick look though. By default, Ubuntu uses GNOME, and I believe also by default Debian uses GNOME. There's also a couple different versions of GNOME. And Plasma is the one that KDE, or Plasma, KDE Plasma. That one would be the one that Kubuntu uses. And XFCE is the one that Xubuntu uses. Cinnamon is commonly used, or most famously used by Linux Mint. And it's kind of looks like Windows XP kind of. But let's just pop into a couple of these while our Ubuntu takes its time. So because we already saw GNOME with Ubuntu, I'm actually going to skip that one for now. Let's pop into LXDE. And for the person who had Lubuntu installed, you'll probably recognize that little bird logo in the corner. Oh, perfect. People are chatting and answering questions in the chat. Love it. Awesome. All right. So this is LXDE. It's very, very low impact on the system. So if we were to open up a terminal, let's see, everyone puts their tools in different places. So let's try QTerminal. If I come in here and say top, let's try top. You can actually see that right now, just having loaded up the thing, we're only using about 10% of our memory, give or take. Oh, hold on, let's do by Control M. Control M. There we go. So we're only using about 3% of our memory, 4% of our memory. So we're not using very much of our memory right now. And if we actually look at megabits or mebibytes of memory, we're using around 1,000 megabytes. That? Oh, that's the total. We're using only about half a gig of memory right now. All right, if we log back out, what you'll see here, this is actually the normal login, and the login screen loads over the terminal. So I'm gonna go for another couple minutes and we'll jump into questions because I know we still want to do that. Or my super secret password. All right. Oh, I forgot to switch my DE. Let's do that real quick. Log out. Switch into Plasma. Plasma tends to be a lot prettier in many people's opinion. It looks like my Ubuntu server has decided to just completely lock up. So unfortunately, I won't be able to do that. But I can do it. Let's save some resources here. I can definitely do it on Debian because what's really cool is because they're all based on the same OS, the commands are very similar between them. All right, this is KDE. And it's a little nicer. It's got some transparency going on. You know, tends to be a bit prettier in people's opinions. What's really cool is if you don't like any of these, you can actually do a lot of custom tuning. So if you should choose, oh, come on, leave, let me out. Oh, there it is, log out. I've not used KDE, so I don't actually know where the logout button is. If you don't like how any of these looks, you can actually super customize your environment and make it look exactly the way you want. So again, really nice because it's open source. You have access to all the files that make your desktop look like it looks. Whereas with Windows, you're kind of limited to the themes that they have, and even Mac is somewhat limited. All right, I'm going to install a web server in the background. While we do that, or while I do that, I will take a couple more questions if there's any that are outstanding. And Corey, I'll ask that you read those for me just while I type a couple commands in here.
Yep. What kind of machine are you using for these VMs? Windows, Mac, etc.
So my host machine is a Windows machine. So my laptop is a Windows laptop. I put VirtualBox inside of it, and then all of these are, currently we're looking at Debian, but also Ubuntu server and desktop, Ubuntu desktop were my guest OSs.
And it looks like most of the questions have been answered in the chat, but if anybody else has a question that has not been addressed yet, go ahead and put it in now. We have about 10 more minutes and then we're going to close out.
Cool. So I did see this one because I was checking here. The minimum specs for running 2 to 3 virtual machines purely comes down to how quickly and how much you want to run. If you're running non-GUI versions, then you can actually get away with a lot smaller memory footprint. The computer that I'm running has 16 gigabytes of memory, and I can run 3 to 4 GUI-based virtual machines reasonably well. I have to tune them back a little bit so they're a little clunky when they're running. If you have 32 gigs, then that gives you a lot more head space. Memory is kind of the more important thing, and the size of your memory is more important. When it comes to your CPU, the bigger the better, and the faster your VMs will run. So, this is chugging along pretty quickly. If I had run too many machines, you'll see that my system resources, actually I can share this too, if it loads. Between doing the video stream for the presentation here, as well as everything else, it tends to kind of eat up resources. So you can see here's where my CPU is at. I'm only using about 8 gigs of my memory, so I could probably pop 2 or 3 more machines open, but then I'd be splitting my CPU between all of them. Oop, let's get back into here.
Also looks like we have one more question in the Q&A box. So where do you get the visual or virtual box, and is it free?
Absolutely, yes. VirtualBox is free, and I will open a side window here. So if you do a Google for VirtualBox, it's actually the Oracle VirtualBox here, or just virtualbox.org. You go under Downloads, and then VirtualBox 6132 platform packages, so Windows, OS X, and Linux. One thing I will note is I saw some performance issues with my 6132 installation on Windows specifically. So I'm actually running version 6130. And if you saw any sort of performance issues, I would recommend rolling back to that 6130. There should be a link somewhere on this page that has old versions available. In general, I do recommend having the most up-to-date and current version of a given software, because you're going to get the latest features. You're also going to get the latest security enhancements. But the problem I was seeing was literally virtual machines freezing. Every virtual machine I opened up would freeze on me. So rolling back was a better option, so I could actually use the software in that case. As soon as they release 34 or whatever the next version is, I will definitely be jumping on that and testing it. All right, so what I've done on the side here is I've actually installed a web server, and it should be up and running. So I can actually open Firefox on here. And then, so I started a web server. What I did is I moved that HTML file that I showed you a little while ago into the var www HTML folder. And this is actually the folder that the Apache server will be reading from. So if I come back here and I say localhost, I did not install HTTPS, so I'm just using basic HTTP. You'll see that localhost Apache 2 Debian default page. So this is just showing you, hey, Apache is here. Apache is working and running. Then what I can do is I can change my path to /hello .html. And there's the web page that I just installed and moved over. Again, I'm not a web developer, so please be merciful on my amazing HTML skills. All right, so let's see here. I'm going to grab a couple of these questions here. If I missed any, please let me know. I'm going back to P6. Slackware. Yep, Slackware is actually a software distribution, just like Debian. So I'm not sure what UI it uses or what DE it uses, even if it does use a DE. It's entirely possible it's totally command line based. I have not directly used Slackware, so I cannot comment any further than that on that one. As for whether or not it's possible to put Linux on a floppy disk and install it on a Windows 95 machine, you would have to find a hypervisor capable of running on a Windows 95 machine. And then there would also have to be a processor capable of virtualizing its processes. So one thing that you don't get to see here is before you even install VirtualBox, you need to go back out into your BIOS and turn on virtualization on your processor. If that's not turned on, VirtualBox probably won't work for you. Some computers have it on by default. Some of them you have to manually go and turn it on. I did watch a nifty video where somebody upgraded a Windows 4.1 system all the way up to Windows 10 though, and that was pretty cool. Looks amazing. You're a web dev pro by now. Thank you very much. I worked super hard on this. It took me like 15 minutes, I tell you what. As for any fitting on a floppy disk, I also kind of doubted that you could fit an entire thing inside of what, 4 megabytes or something, 8 megabytes. That would be a teeny, tiny small Linux. There is one called, I believe, and pardon, damn small Linux. I don't know how big it is, but it is microscopic. So that one might be one to look into. And yes, I 100% agree with Mark. There's a distribution called Kali. It's commonly used for security researchers and hackers. Do not run that as your primary distribution. Anything you can do in Kali, you can do in another distribution if you download the right software, the right package. However, Kali is not secure. It is not designed for day-to-day use. It is horrible for day-to-day use. The best way to think of Kali is think of it as a screwdriver sitting in your tool bag that you pull out every now and then when you need it, but otherwise it stays in your tool bag until you need it. So I will absolutely echo that. All right, that's all I've got unless there's any more questions, or I'll hand it back to you.
Looks like we have all the questions answers, guys. Thank you again for coming out for our event this evening. Big thank you to Adam for leading this incredible event. And we hope to see you all again soon. This video not only will be sent to all participants that came tonight, but it will also be posted to our YouTube channel. And then the slide deck that he presented with will also be included. So you guys should see that in the next 3 business days. Have a good night, everybody. Thanks again for coming, and we hope to see you soon. Bye.